Hey guys, so today we're going to start our next chapter, and I will tell you this year, this is actually chapter 6. Okay, now for regulars and honors, just be clear enough what I want you to accomplish for the day's lesson, because as you can see, like 6.2, honors will only be doing that. You'll see that regulars for graphing sine and cosine, you'll have a little bit of a leeway if you want to do the whole lesson today, or if you want to split it in half, things like that, okay? So what we are actually going to do in this chapter is we are going to learn how to graph sine, cosine, and tangent. Now, I know there are 6 trig functions, but we're only going to focus this year on sine, cosine, and tangent. We're actually going to relate this to something we did earlier this year, okay? Because we learned earlier this year, when graphing any functions, we should do it by transformations. So first of all, I'm going to show you what the graph looks like and the parts of the graph. And then I'm going to show you how to graph. So this is our sine function. This is our cosine function. Now, as you can see, it's a wave, right? This wave continues negative infinity to infinity, okay? And if you relate this back to the unit circle, you can see that these points right here are the points on the unit circle. So if you say, hey, at 0 radians, sine is 0. At pi over 2, sine is at 1. At pi, sine is 0. At 3 pi over 2, sine is negative 1. And at sine is pi, 2 pi, sorry, we're back at 0. And then it repeats over and over and over. If we look at cosine, you see the same thing, except we got to remember that on our unit circle, cosine is the first coordinate of that coordinate pair. So at 0, cosine is 1. At pi over 2, cosine 0. At pi, cosine's negative 1. 3 pi over 2, cosine 0. And at 2 pi, we are back at 1. Now, you guys see how I just made these 5 points? And we were back at where we started. This is what we call the period. So that certain type of wave keeps repeating itself over and over and over. So period tells us how big that wave is. Now, how to find that period, you would take 2 pi over the absolute value of b. Well, what is b? Well, look at this function and how this is set up. Okay, so b, which is multiplied by x, that helps you with your period. It's not exactly your period. Your period is 2 pi over b. So if I ever ask you to identify what the period is, you'll take 2 pi divided by the absolute value of b. Now, as you can see, I skipped a part, and we might as well go back. Sorry, I guess my nose is stuffed. Back to the function. As you can see, the function itself starts with a. Well, what is a? A is the amplitude. The amplitude is half the distance from the max to the min. So of course, your maximum, your minimum. Okay. So the idea is your amplitude halfway is that distance, because this amplitude is going to be the same from that halfway to the max, halfway to the min. Okay, so that's your amplitude. And then we have k. Well, what was this number, or what did this number do for parent functions? Well, it moved our graph up or down. And when we talk about moving sine and cosine up or down, we're moving that middle part. We're moving that midline, which is right here. So this is where it starts, that halfway, okay? So of course, k shifts at midline. Now, I'm going to show you how to break down these actual characteristics to each function, but then I'm going to show you how to graph. Some teachers use these characteristics to graph. I'm going to do it by transformations just so we relate it to the beginning of the year, and it becomes easier if you have to graph multiple periods, which in 1060 you will call it string. So let's go over midline. Midline comes from what happens with k. So k is -1. So our midline is going down 1. And we can see that at -1. Okay. Amplitude is that A part. That's what's in front right there. So that's my A. So my amplitude is 2. Okay. My period comes from B. It is not B, it comes from B. So I take that B value, that value in front of X. Remember, period is 2 pi over the absolute value of 3 pi. So of course, if we were to calculate this out, our period would be 2/3. Again, what does that tell you? Well, that means wherever we start, our one revolution would end up at 2/3. Before we graph, just to tell you, this is how you know if you graph correctly, because your sine will always start at the midline. Okay, your sine will always start at the midline. Now, if I go to the right, it moves up if our function is positive. If our function is negative, it starts going down. So remember, a negative of a function flips it. Okay. Our cosine will start up at our max. Okay. And go down. Now, if it was a negative function, it would start down and go up. So I want you guys to see, let me see if I can get a marker. Sine will start at the midline and make a wave like this, where cosine will make a valley. Or if it were upside down, it would make a hill. Okay. And this, what I did purple here, is one period. Okay, I'm okay with you guys graphing one period, but in the future, like in 1060, you will have to graph 2 or more. Now, I said I was going to relate this to transformations, right? So this is sine. Okay, so the first thing I'm going to do is write down the coordinates for our parent function. And I'm only going to do one period or one rotation. Okay, so some nice easy coordinates for sine is at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Again, that is a full rotation of the unit circle, right? And then we'll go over coordinates, right? So just the parent function of sine starts at 0, 0. At pi over 2, sine is 1. At pi, sine is 0. At 3 pi over 2, sine is -1. And at 2 pi, we're back at 0. Okay, so when we do sine functions, we're always going to start with this table. Okay, now remember, from transformations, Anything on the inside, we do to X, but we have to do the opposite of what we're thinking. And then on the outside, we do it to Y in order from left to right. Okay, so let's start with our Y's. On the outside of this function, we have 2 and -1. Okay, so I'm going to go left to right. So the first thing I'm going to do is multiply the Y value by 2. So we get 0, 2, 0, -2, and 0. Then what we're going to do is subtract 1, right? Because that was our second step. So 0 minus -1 is -1, or 0 minus 1, sorry. 2 minus 1 is 1. 0 minus 1 is -1. -2 minus 1 is -3. And 0 minus 1 is -1. Okay, so that's my Y's. Let's see, do I have another color? Now on the inside, we have this 3 pi. Now remember, what did we do? We have to do the opposite to what we're thinking. So 3 pi is multiplied by X. So what we have to do is divide it by 3 pi. Opposite. Okay. So 0 divided by 3 pi is 0. 2 pi over 2 divided by 3 pi. So on the side here, I'm going to show you what I'm talking about. Pi over 2 divided by 3 pi. Dividing by a fraction is the same thing as multiplying by its reciprocal. Okay. All right, and what do you know? These pi's cross out, right? Pi over pi is 1. So we're left with 1/6. Okay. And then I'll do my next one. I'll just continue doing this until I run out of room, okay? Now we have pi divided by 3 pi. Again, what happens to those pi's? Leaving us with 1/3. Okay. 3 pi over 2 divided by 3 pi. Again, writing this down is the best way to know that you're doing your calculations correct. So multiply by its reciprocal. And then what happens here? Well, as you can see here, we get 1/2 right there, right? Okay, last one. So we're going 2 pi divided by 3 pi. What happens to those pi's? Cancel and we get 2/3. Now, this is how you know you're on the right track. Because when you do one revolution in your table, you end up with your period. You end up with your period. If you don't, you did something incorrect, okay? So this is a good way to check yourself. Now, graphing. Sometimes you need to move your y-axis over a little bit. As you can see, all of this, my x's here are positive, okay? And my y's go back and forth. So what I might do is start my y-axis right here. Okay, and I see my y's go from -3 to 1. So I'm just also going to put this in the middle just in case. Okay, and now I'm going to plot these points. So I'm going to label this. I'm going to go 1, 2, 3, -1, -2, -3. Okay. Now, here's the tricky part. What I would do is label your graph based on your x values right here. So of course, 0 starts at that origin. Then you know what? And I want this not squished. I want this spaced out because all I'm doing are 5 points, right? So I might do every 2. So there's 1/6. There's 1/3. There's 1/2. And there's 2/3. Okay. I did that based on my table. Now I'm going to plot my points. I'll do this in red. Where's my other red pen? Let's see which one of these works. Okay. So I'm just going to plot my points. So I'm at 0, -1. Remember, it's your outer points that you're graphing. I'm at 1/6, 1. I'm at 1/3, -1. I'm at 1/2, -3. And I'm at 2/3, -1. And there is my graph. Now, I am going to use all of my characteristics that we solved over here to help me know that I did this 100% correct, okay? First of all, I know I've done good so far because again, my period, right? Sine, where did the function of sine start? It starts at the midline. What do you know? There's my middle, right? And also look at this, my midline is at -1. Check that off, right? Check that off. And let's go, my midline up to my max is 2. My midline down to my min is 2. Amplitude is 2. So we graphed it correctly. This is sine. If you are in secondary 3, considering we are doing this for 2 days just for the secondary 3 group, you may stop right now and do the assignment part that has sine on it. If you want to continue taking notes because cosine is part of your 2 days, you can do that also. Okay, honors, keep going. Okay. All right, let's see what we got here. First of all, I want you to notice that this is negative. So that means we're going to flip. Okay, so I'm just making a note of that because I want to think of flipping. Okay, midline, where does that come from again? That comes from our cave right there. So we're going up 3. Amplitude is our A out front. Now, I would rather you guys say the amplitude is 5, considering amplitude is that distance from the midline, because that negative, all that does is flip it, but that distance of 5 is still the same whether you go up or down. Okay. Period comes from what's in front of x, right? That b, it comes from it. It's not exactly it. Okay. So if we remember, period for sine and cosine is 2 pi over the absolute value of b. Okay. Now there's our mathematics skills, right? Dividing by a fraction is the same thing as multiplying by its reciprocal. So what do we get? Our period is going to be 4 pi. All right. Remember, if there's any questions, pause and ask. Okay, so we're doing cosine. We're going to do our parent function first. Okay, so we have x, y. We're going to use the same radians for x's as we did for sine. So we're going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. But in this case, since we're doing cosine, our y value is different. At 0, cosine was 1. I don't know why I put -1. At pi over 2, cosine is 0. At pi, cosine's -1. At 3 pi over 2, cosine is 0. And when we're back at our rotation there, at 2 pi, cosine is 1. Again, if you want to double check, you can look at your unit circle and look at those coordinates. Outside stuff goes to y. So now I'm going to do -5. I'm going to do that negative with it because hopefully that negative flips my graph, right? Okay, so I'm going to multiply my -5. Sorry, guys. And I am out. Now let's try a new pencil. Okay. I am going to multiply by -5. So we get -5, 0, 5, 0, -5. Then we're going to add 3. -5 plus 3 is -2. 0 plus 3 is 3. 5 plus 3 is 8. 0 plus 3 is 3. -5 plus 3 is -2. Okay, and on the x value right there, we are going to remember do the opposite to what we think. So instead of multiplying by 1/2, we either divide by 1/2 or multiply by 2. So multiply by the reciprocal. So 0, pi, right? 2, or pi over 2 times 2. The 2's cancel, right? Pi times 2 is 2 pi. 3 pi over 2 times 2, well, the 2's would cancel, right? So we would get 3 pi. And 2 times 2 pi is 4, 45, 4 pi. How do we know we're on the right track? Because we ended our table with our period. See, our period's 4 pi. There we go. Okay. Now, let's see what else. Okay, now let's graph and then we'll compare our features. Okay. Now, when we graph, as you can see, I'm still in the positives here. So I might just go over to for my y-axis. Now, this is where I want to make sure that my x-axis is in the right spot because I want to use this graph and not go over. Okay. As you can see, my highest is 8 and my lowest is -2. So let's see, how many spaces do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14. All right, so let's say if 8 was right here. So 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so let's make our x-axis right here. So see how I had to count that to make sure it fits on my graph. I did that by looking at my max, which was 8, and my min, which was 2. Okay. So of course this is 1, 2, 3, 4, 5, 6, 7, 8. And this is -1, -2. All right. Here Now it's going to look like I'm spacing my graph the same way I did on my first question, but hopefully that recorded. My computer just decided to stop recording there. So, okay. But as you can see, we're in different units here. So this is going to be 0, pi over 2, pi, 3 pi over 2. Why did I say 3 pi over 2? I meant 3 pi. There we go. Looking at the wrong column. And then 4 pi. Okay, and now I'm going to plot my points. I'll do it with this one. So we're at 0, -2, pi, or pi. What did I do? Oh, I know what I did. Ha ha ha. Do you guys see that? I put pi over 2 instead of pi. Okay, sorry guys. I'm hoping I have enough time to piece these parts together. Apparently I ran out of room on my desktop. So here's where we are. We just plotted, or we saw my mistake on the x-axis, and now we're plotting these points. So at pi, we're at 3. Oh, it is not my day, is it? Pi is at 3. At 2 pi, we are at 8. At 3 pi, we are at 3. And at 4 pi, we are at -2. Of course, if I make sure it's like a wave, guys, not a V, like it's going to continue, okay? Let's double check that we are correct. Remember, cosine looks like a valley or a hill, and it's supposed to be a hill because it's flipped, so we're all good there. Let's talk about our midline. Our midline, well, the middle of the graph right there is at 3, so we're good. The amplitude is 5 away, so here's the midline. So let's go 1, 2, 3, 4, 5. That's great. 1, 2, 3, 4, 5. That's also right. So I checked off all of my features and I'm good to go. All right, next, last part. Hopefully my computer doesn't die. We're going to go backwards. We're going to say, hey, here's the graph and let's make an equation for it. So actually what we're going to do is fill out these ideas first and then create an equation. Okay. Now, first of all, I want you to see that where we start is what do you know at the midline. So what type of graph is that? That is a sine graph. So I'm going to say f of x equals, now amplitude sine something x plus or minus so on and so forth, right? Okay, so let's go back. Let's see, where is that midline at? Well, that midline is at 2. Okay, and it went up. Now, amplitude is midline to the max or midline to the min. So 1, 2, 3. So the amplitude is 3. Now, the period, here's where it gets tricky. First thing we're going to do is count where that full cycle. So if we start in the middle, we've got to have a full-on wave till we hit the middle. So we hit the middle right there. If you look straight down, that means our period is at 2 pi. Okay. Now we're looking for the b in our function. So what we do is we set this equal to 2 pi over b. Now in this case, hopefully you guys can recognize it, that of course, what's the number for b in this case? It's 1. Well, what if we had to solve it? Well, what I would do is multiply both sides by b. So we would get 2 pi times b equals 2 pi. Solve for b. What do we do next? Well, b is 2 pi over 2 pi, which is the value of 1. So b is 1. I'm actually going to write that in for b. Do you have to write down 1? No. So let's put these numbers in. So we're going up 2 for the midline. Where's the midline happen on our equation. If you have to go back to that first page, that's what we add or subtract on the outside there. Where does the amplitude come from? Well, that is our A, the great thing, amplitude A, right? And A is in front. And then our B is what goes in front of X. One more thing to keep in mind. Where did we start this? We started it in the middle, but which way do we go? We go down. How do we indicate that in our equation? Well, it's like we flipped that equation, right? So what we do when we flip is we make a negative up front. Okay, that's how we go backwards. Let's try it again. Remember, the first thing I did was look at where we started. Right here, we start at the top. When we start at the top or the bottom, what function are we looking at? Well, when we start at the top or the bottom, we're looking at cosine. Now again, I'm just putting spaces in just in case we have certain numbers there. Okay, now let's look at our midline. The middle of the graph is right here. That's at -4. So that's at down 4 or -4, you can say. Amplitude. How much did we go to the max? How much to the bottom? Well, that is just 1. Okay, period. Remember, in this case for cosine, a period is a full valley or a full hill. So right there is our full valley. That means that our period is at pi. Okay, so that's our period. But again, we don't put the period inside the function. We have to solve for b. Okay, so we set that equal to 2 pi over b. Some of you might recognize what b is right now, but I'm going to do it mathematically. I'm going to multiply both sides by b. Okay, and then I'm going to get b by itself by dividing by pi. And what does that simplify to? Simplifies to 2. Okay. Midline, down 4, that's on the outside at the end. Amplitude is 1, that's what we put out front in front of our function. And then the period, well, the b is 2, and that goes in front of x. Double check. We started at the top for cosine. So this is good. That means that's positive. It would be negative if we started at the bottom. All right, like I said, I apologize now if each of these videos are separated. I'm going to try to put them all together. Your practice work is on paper, okay?